Hello, welcome to lesson 2 of Java variables, how we're going to declare them, the sizes of the data types, and we're going to go ahead and talk about formatting in the System.out.printf method. So let's go on here to the primitive data types. Just note that at the bottom here I put string because I'd like to talk about it, but just know that it is not actually a primitive data type. It's a method or class that was created by Java to include combinations of primitive data types, including the integers, the doubles, and the chars. So here we have numbers at the top from a byte to long. The significance is the size of data that is referenced in the application for the declared variable and the values that it can hold. We also have decimals, so if you wanted to use a fraction of a number like 5.5, we would need to declare a float or a double. Just note that the floats are 4 bytes and the doubles are 8 bytes. You can also see that the float is 7 decimal digits, or the double can go up to 16. We also have the char, which is a character. So it holds 2 bytes. Some characters are only 1 byte in length, but some are 2, so we declare 2 bytes. And we also have a boolean, which literally holds true or false. And we'll see that in the application as we go along here. So let's go ahead and go to the formatting here. So we'll start a new application. It'll be a Java application. We'll name it Variable Declarations. Here in our public static void main, we're going to declare my age. So we'll start with the data type, which will be an integer. We'll name it my age, and we can set it equal to 28. If you'd like to add information about the variables, or as you comment your code, so that it's easier to read, you can use 2 forward slashes. 2 forward slashes, it signifies that the text after it will not be run by the compiler. For demonstration purposes, I'll put here, this is my age. Then we can also declare another one, int your age, but we don't need to assign the value here. We can assign the value later. So let's say we progress through our code and now we want to declare your age. So we can say your age is equal to 24. But let's say a year goes by and we want to re-reference my age. So now we can say my age is equal to 29. So let's go ahead and print our data to the screen. So we want to know what happens in our code. So we'll do a system.out.print line. Notice I'm doing the print line here. And we can say my age is, and the quotations, to add our variables, we add a plus sign, add the variable type, so my age. Then we're going to say your age is plus your age. We can go ahead and run our code here and see how it says my age is 29 and your age is 24. But notice how ugly that code looks. We had to use 4 different double quotes, and we also had to use 3 different plus signs. It would be much easier if we could just reference directly in our code. So this is where printf comes in handy. So here, let's say system.out.printf for format, and we can say my age is %d and your age is %d. After we declare what our formatting should say, we declare the arguments. So in order from the first one that we say to the last, we want to declare my age first, so we'll say my age, and then we declare the second %d, which is your age. If we run this code here, we'll see it's the same exact. My age is 29 and your age is 24, but it's much nicer. And it helps for scalability too, because we can go along later and add more data types there. But where did I get this %d? What does a %d mean? If I were to change this my age to, like, let's say my name, we couldn't use a %d because that was a string. So let's go ahead and talk about the formatting here. So in the printf, we have the format, which we saw with the double quotes and our text. And then we have the arguments, which are the data types. We could put methods here as long as the data type is eventually called. So the D that we used is a decimal. It's basically a number. So in our application we used the age, so that was just a simple number. But if we wanted to use the price of something, we could use F, which is formatting, or a floating number. So let's go ahead and try F and see what it does. So let's declare a double computer price equals $100.50. It's a pretty cheap computer, isn't it? So now that we have the price, let's go ahead and make a system out, printf. The computer price is, and for this one we were using the percent and F for the floating point number. And then we'll go ahead and name it the computer price. Now if I run this right now, you'll notice that it will just continue on because the printf by default does not have any new lines. So to add a new line, we can use the percent %n. I'm going to put 2 just so it kind of puts it 2 lines down. See how it created 2 new lines here? And I can get rid of that space to be formatted a little bit better. But notice how I set the computer price to 100.50 and it outputted 100.57 decimal digits. That's because by default the double is 7 decimal digits and the float is 16, or vice versa. Double is 7 and float is 16. So back to the application here. If I want to format the output of my decimal to only be 2 decimal digits, I can put 0.2f, which will format the output to 2 decimal digits. So now if I run the application, you can see that it says the computer price is 100.50, which looks much better. And if I wanted to add a $sign, I could. So our application is looking much better now. So let's go in and add a string as well to show the string. So a string is equal, well, we have to declare a name of it. So we'll say the name, my name, is equal to Tyler. And then in the output here, we'll do System.out.printf %n for a new line. My name is % and S for a string. My name. Now if we run the application, we see that it says my name is Tyler. So we've talked about kind of different data types, different variables. Now let's see what happens if we were to set a data type that does not match its size, the error message that we would get in our application. So for demonstration purposes, I will set a, let's do a byte since it's only 4 bits in size, to 500 to see what would happen. So byte failed code equals 500. Notice that it instantly gives me an error code, incompatible types, possible lousy conversion from int to byte, because we just declared an integer and we're trying to force it to be a byte. So now if I were to do a System.out.print line of the failed code and try and run the application, you'll notice that it says that there are errors. And this is important debugging information about your code here. It'll say there's an exception. It'll tell you on the line that the exception is occurring, line 35, and it tells you a little bit about the error, incompatible types. So you can see here that we declared a byte even though the failed code should not have been a byte because it's not the right data type. This NetBeans is kind of cool because it shows you how to fix things as well. So if you hold Alt and press Enter on the code, it will say cast 500 to a byte or change it to a int. The proper way would be to change it to an int. We could try and cast it to a byte, but it will not hold as well. So we're going to change this to an int, and notice that when we run, it now works properly. So that was just a little bit about Java variables, their associated sizes, and primitive data types. Just note that string is not a primitive data type, and a little bit of formatting with the system out print format.